Hey everyone, welcome to the 24th episode of the Coffee with Cosmos DB series. Probably this is the final episode for this year. If you missed to join the stream last time, you can watch the recording. Also, if you are interested to present in the channel, please submit your talk via the link displayed below in the description of this video. If you would like to know more about a particular topic or a feature, you can post in the chat, or there is a community tab discussion. You can post it there as well. So this series is all about spreading the knowledge on Cosmos DB by the experts to the community. So please make sure to subscribe the channel and share this with the community members who are looking to learn more about Azure Cosmos DB. If you're interested to present or have any feedback, please reach out to me, and thanks for all the feedback so far. With that, let me introduce our guest for today. Hi, Mihai.
Hey Sanjay, how are you?
Yeah, doing well. Today we have Mihai, who is a principal software engineer at Independent Data Lab and also open source contributor. It's great to have you in this show today.
Yeah, thank you for having me.
Yeah, I have seen your conference talks and also contributions around the data streaming with Benthos. I guess you're going to cover the same topic today with and also to use it with Cosmos DB. Yeah, excited to hear and learn from you. Those who have any questions, please post them in the chat. Yeah, take it over.
Yeah,
Mihai.
thank you, Sanjay, and thank you for the nice introduction. So, like Sanjay mentioned, I'm a Benthos contributor, and Benthos is a data streaming processor written in Golang. It's fully open source. And this is something I've been using for the past three and a half years for my work. I used to work for a company called Optum, part of United Health. You might have heard of it. It's a really big company. And inside there, I had several projects where Benthos proved to be this really useful tool for data streaming and for moving data across different systems. It's pretty generic. So you can use it to plug into various database engines, lots of batching workflows, lots of ETL workflows, or you can even use it for real-time processing, like hooking to Kafka and stream some data somewhere and maybe transform it in flight, etc. And one of the projects I had, we were looking at Cosmos DB. There was a bunch of data already sitting in there, and the idea was either to read it from Cosmos DB and store it somewhere else, some internal system, or use some internal system and send data to Cosmos DB and do it in a scalable way. Like, imagine Benthos is just a static binary, like single application that you can run in your terminal, or you can run it in a container somewhere in Kubernetes or wherever you want. And it's easy to develop a pipeline. Like you can see, it's configured by YAML. So you can give it an input, some processing pipeline and output, or you can have multiple inputs and multiple outputs, whatever you want. And the idea is that it proved to be very simple to have these reusable pipelines that people can just plug and play. And because of the Cosmos DB need, I started experimenting with the Cosmos DB API, and I wanted to see if it would be feasible to add to Benthos this kind of integration that people might use. And because it's open source, I thought I can push the code upstream so that other people can benefit from it and maybe use it for their own projects if they want to play around with Cosmos DB. So I guess everyone who's tuning in here knows about Cosmos DB, but at a high level, it's a NoSQL database. So you can store arbitrary structured documents in it. However, they do need to have certain fields, like they need to have an ID field, which should be unique per document, and they need to have a partition key. So that's another field that needs to be there, and I can talk a bit more about that later. But in general, Cosmos DB comes with drivers for every language out there, for every popular language out there. But because Benthos is written in Golang, here we're going to look specifically at the Golang drivers, and there's an official one called AZ Cosmos. You can find it here on GitHub. And this one has, quite a few details in here that I'm probably not gonna go into a lot of detailed bits and pieces. I don't want to bore you too much. You can explore it yourself, but we do need a few things in the Benthos world to develop something like an integration. So in my example, I'm going to show you an output, and you're going to see how that got put together, and I'm also going to play with it. But in order to kind of experiment with this output, I need to have my own Cosmos DB running, and I don't have an account there that I can use right now. So I'm using the emulator that Cosmos DB provides. So here, there's a Docker container that's being offered by Cosmos DB that you can just run yourself. So let's just do that. I have a remote machine that I'm going to SSH into. Hopefully this just works. Yay.
Mihai, there is a question
ahead.
on the chat.
Yeah.
Can we take that up?
Okay, yeah.
Is it similar to Kafka? I think they're referring to benthos.dev.
Yeah, that's something I should have mentioned. And let me show you a diagram. So Benthos is stateless. Benthos doesn't have any state by default. You can configure it to use a cache if needed. But Kafka is an auxiliary system that you can use with Benthos. But you shouldn't regard Benthos as Kafka. You should regard Benthos as a kind of a tunnel or a pipeline that can do many processing steps. But at the end of the day, if you hook it up to Kafka, it will not attempt to buffer messages inside it. You can configure it to do that, but by default, you would say, hey, can Benthos write to the output? If the output is down, Benthos is just going to stop reading from the input. It's going to apply back pressure and stop reading any message. And it has all these bells and whistles inside it. Like you have batching that you can configure, you have rate limiting, etc. But again, it's a very very much stateless, and
Okay.
it has a bunch of nice properties. Like for example, for delivery, for message delivery, it does more than once delivery guarantees. So if you have a message that fails to be delivered, it will keep attempting to deliver that, and it tries really hard to make sure it doesn't lose any data. So you might get duplicates, but that's another story.
Got it. Thanks.
Welcome. So getting back to this, we were trying to run that emulator. So I'm going to run this Docker command here. There's a bunch of details in here, but you can set this partition count. So, it's like not using too many resources. I'm setting it to 10. I think that's a good number. And then we can do Docker logs -f. Bit lazy. So now we can see it starting up, and it's starting up pretty quickly. So it's running. And then there's a bit of gotcha there, because by default, the endpoint that this container exposes has a certificate that you need to pull down and install, but I don't want to do that. So what I'm going to do is run a local reverse proxy, which is going to say, well, take HTTP requests from local hosts and forward them to this HTTPS endpoint and ignore certificate errors. So I have this MITM proxy running here, and now if I open localhost 8080 where the proxy listens on, you're going to see that I can access my emulator. Here we go. So we have a very empty Cosmos DB emulator. So let's try to start with a new database, and we can create our users database. Leave the defaults. I have the users database, and we're going to create a container. Oh, sorry, I wanted to actually name it testdb. Sorry about that. And I wanted the container to be users. There we go, testdb created, and now new container, we can name that users. We can have a department as the partition key. So this is a field that every document we put in there must contain. I created that. It's here and it's empty. Okay. So now if we look at Benthos, I have a bunch of configurations here for it. And here's one that uses my output. So what do we see in here? So we have a generate input. This just generates a bunch of dummy messages. Let's start with a single message. I'm going to talk about the settings in a bit. But here we have a bunch of departments that we want to use. And I'm just going to use a static department. I'm just going to say, well, for my current message, I'm going to use the engineering department, for example. And the reason I'm doing this is because of this partition key that needs to be fixed. If I emit a batch of messages, I cannot have them just be in random departments. So I need to make sure that when I construct a Benthos batch, I'm using a fixed department. And this might not make perfect sense, but anyway, I'm just going to go with it. So we have an ID here. I'm pre-populating the message ID, the document ID with a random UID, and I'm just generating some fake data. So we're going to see what happens if I use this fake function. It just generates a bunch of random strings. And the document is going to have these fields in it. And as you can see here in the Cosmos DB output, we have a bunch of mandatory fields. So we have the endpoint, which I'm setting it to that proxy endpoint, the account key, which I'm basically just getting from the emulator window here. And then the database testDB, the one we created, the container users, the partition key. This is Benthos interpolation. So it uses a dynamic key. And I'm just saying, well, this has to be the value of the department in the current message. So I'm using this JSON function. I'm extracting the value of the department that I set in here, which is going to be this fixed engineering or legal, whatever index of 1 is, I guess. Yeah, probably use 0. That's engineering. Anyway, so I have to also mention the partition key type. This might change in the future, but for now I'm just telling it is a string. And this is because of the way the driver works. And I'm also telling it, hey, don't generate the ID because I'm giving you that. But we can also set this to true, and that's a convenience that I built in such that you don't have to necessarily add this ID here explicitly. You can have the output generated for you if you want to. And then I'm saying that the operation is create, so I'm creating documents. But this can be something like delete or replace. We can see all the operations that are available later. And I'm also configuring batching. So here I'm basically disabling it by setting everything to 1. And the max in flight represents the number of batches that are in flight at the same time. So let's just create a single document and see how that goes. And this is right. So I created a document. And if we go in here, we should be able to see our item. So this got interesting because it contains a bunch more fields that get created implicitly by Cosmos DB. But we can see the data we forwarded here. And, this is the random data that we generated, the name, the username, the ID, etc. Right, and you can see this is pretty much work in progress. Like this output is not currently in Benthos. I have a pull request that is kind of work in progress, and eventually I might do another presentation where I kind of show you, hey, this got merged, and now you can use it as you want. But for now, it's kind of work in progress. So yeah, we have.
I guess there's a follow-up question on the
Go ahead.
previous information that you shared. You talked about Kafka and it's being stateless, right? So yeah, there is a question. What about the delivery guarantees if it's stateless?
Right. So it does at least once delivery. So if it reads from Kafka, a message, you'll try to send it to the output over and over and over until the output acknowledges that, hey, I wrote this message. And that acknowledgement is then propagated to Kafka. And then Kafka stores that offset increase. And then the message is considered to be delivered.
Got it. Okay.
So that's how it works. But you can get
And
duplication.
here you mentioned you are using the local host because it's an emulator, but I mean, the endpoint can be anywhere, right?
Yeah.
If it's okay, got it.
Yeah. So normally you would set this to your Cosmos DB endpoint.
Cosmos DB account. Okay.
Yeah.
Okay.
And we can go into that a bit later because I can actually have a field here where I can say connection string. So that's another option that the driver gives me, but we can discuss the API.
Okay.
So now let's scale this up. And this is the nice part about having something like Benthos versus, hey, I'm just going to import the Cosmos DB driver and write my own CLI tool. You get all sorts of things for free. Like right now, I just want to send 10,000 messages like that. Well, I can send them one by one, but that's going to be a bit slow, isn't it? So I can batch them, and I can say the number of parallel batches. So now I'm doing 10 batches in parallel, and each batch contains 100 items. So let's see that happen. So it takes a bit of time, but not too much. You see it finished. Excuse me. So now if we go in here, we should see a whole bunch of users, right? Cool. And we can even do, oops, not what I meant. In SQL query, we can do count c.id. So you see we have 10,001 users. And I actually picked 100 here deliberately because there's a bunch of limits you need to be aware of when working with Cosmos DB. So if we look here, it does say that there's a maximal number of operations in a transactional batch, which is 100. So what is a transactional batch? Well, if we look here in the documentation, there's somewhere here, there's a transactional batch item. And this lets you bundle up operations to be executed as a single transaction. That's kind of nice because like we take a Benthos batch and we want to send it to Cosmos DB as a single unit. So if a single message fails, the whole batch is failed and we try it again rather than, well, I kind of stored most of the messages in the batch, but this one's failed. So then I'm going to try again. It gets a bit messy, right? So you kind of want to just reject the whole batch. So that's nice. So I can set this. I actually made it right now that you can set this to something higher and then just get a warning and the batch gets split up internally. But I think that's just wrong. I should just reject batches that are too big. And it's always good practice to set a period here as well, because if it just happens that the input doesn't produce batches that can be evenly split into 100 items, then you just hang on the last batch and just keep waiting forever because it never fills up. And the max in flight is parallelism, and you have to be careful with this because you're basically telling Benthos, well, spin up this many worker threads internally, or go routines I should say, and have those write in parallel to the output. So you can probably overwhelm your Cosmos DB. I don't know what the limits are. I will have to play with it, but you can go crazy here. And like you can do this and maybe emit a lot more items and have it as a long running process. But in that case, like if it runs for 2-3 hours, you have to think of metrics, and that's something that Benthos does quite well out of the box. So if you go into the documentation, you can see here has a whole bunch of metrics you can watch. So you can use your Prometheus or whatever to look at all these metrics and make sure everything is up and running. So this is kind of batteries included. You can use it for free. Also tracers, have logging as well. So kind of selling it now, but these are things that you probably want for production system that are pretty hard to build from scratch. Right. So now what can we do? Well, we have this data in Cosmos DB, but like how do we get it out? And that's where things get interesting, because Cosmos DB does support some sort of SQL-like language. I mean, I'm saying SQL-like because there's a bunch of things that are slightly different from your Postgres database. You can kind of run SQL queries, but some things just are a bit awkward to express. And this is where I wanted to introduce a third-party driver that you should probably not be using in production, but I kind of became aware of it by searching on GitHub. Actually, I had it open right here. So this is called Go Cosmos, and this is interesting because it attempts to fit in with a database SQL package. And this is like the standard library SQL package that you have inside Golang. And the nice part about being compatible with this database SQL package is that, well, technically you think you can just get away with something really simple, like, well, maybe I should show you that example. You import Go Cosmos like this, and then you configure a DSN, and you do SQL open and then DB exec, and that's it. Like, you can literally use this to select data from Cosmos DB, which is kind of cool. But like I said, because it's not, like there's some special handling in the queries that are kind of different from the way Postgres works, for example, things might get a bit wonky. And I was trying to play with it, and I found that, being a third-party package, and under the hood, it doesn't even attempt to use AZ Cosmos, which is another problem. It hits the REST API directly. So from this perspective, I don't think we should be using that in production, and I'm probably going to have an input that is not based on Go Cosmos, but for now we're just going to go with it as a demo. So Benthos has a bunch of this nice utilities for selecting data. So for example, here for databases, we have the SQL raw and SQL select inputs, and these are generic, so you can have in them multiple drivers, like we have here all these other drivers. For example, imagine you want to like bulk read data from Cosmos DB and put it in MySQL, or vice versa. That could be one use case. So here we're trying to select from Go Cosmos. I constructed a DSN where I'm just putting in the emulator DSN. And you see it already has a bunch of utilities under the hood. Like here, it says insecure skip verify. You can basically tell it ignore certificate errors. We don't have to go through that local host proxy. It also does auto ID if you want to do that, if you want to output data. Anyway, and I'm also telling it what the database is. So then I can write this SQL query, and it should just give me data. So let's try that a bit. And mind you, now I have quite a lot of data in there, and I'm kind of scratching my head. I'm not sure what mechanism I have to limit the number of rows returned. So I'm just going to clean up the data. That would be the easiest thing to do, I think. And just write a bit less data for now. Users. STP. So now let's just put a bit fewer items in there. 10 is usually a good number. Right, and now we want to select the data. So you see we're getting the data from Cosmos DB, and we have all these fields here. Now let's say we want to massage this a bit, like maybe we don't care about the ID, it's just an internal Cosmos DB ID. So if you look here, I had this processor that was commented out. Let's just put this in here, and here we can see an embedded DSL from Benthos called bloblang, and this lets us massage the data. So I'm just saying, well, instead of taking the document as is, I just need two fields, name and username. And for the username, you see it's kind of ugly, it has uppercase and lowercase letters. Maybe I just want them to be all lowercase. So let's do that. You can see we got the data as expected. And I'm just showing you the simplest stuff possible. Like here, we can go crazy and write a very complex transformation. Also, these documents are fairly simple. Like there's no nested objects here, but we can totally have nested objects inside it, and we can dig inside those and do those things. So now I don't have that much time. I'm not gonna demo a lot more stuff, but the idea is I can have like a cache in here, and I can think of a situation where I might want to join data across two containers, right? So then I can have a sequence input where I read this whole data and put it into a cache. So I can tell Benthos, hey, you have this cache, put all these 10 items inside that cache, and then I can have another SQL raw input from another container inside Cosmos DB. And then I can say, well, read all the data from that container, but then filter it down based on the items in this cache, right? So that way you can do, for example, a kind of a join across two containers. So that could be an interesting use case, I suppose. And by caches, well, if we look in here, you see there's support for quite a few types of caches. You can use the in-memory one. You can use Redis, for example, as an external cache. So enough talk. Let's look at the code a tiny bit. So here I'm only supporting one mechanism for connecting, and I show you at a high level what it takes to write a Benthos output. So for an output, you basically want to create a type. It's a struct. It contains a bunch of fields. Let's not worry about this too much. But it needs to do three things. It needs to connect, it needs to write batches, and close. And the connect, well, things are pretty simple with Cosmos DB because we just pull in the client key, and we create this client, and then we can, here is kind of a utility that I built in. Hey, if the container doesn't exist, create it on the fly. I'm probably going to make this optional because otherwise people might get tripped up. And in practice, you might not have permissions to create containers, whatever. But then inside write batch, there's a whole bunch of handling here, like in various plumbing that you need to do with Benthos. Let's not worry too much about it. But if we look at this part here, this says, well, container execute transactional batch, and that goes into the transactional batch functionality that I was showing you before. Still have it here. So this transactional batches here. So this can let us do various operations. You see it has create item, delete item, patch item. And patch item seems to be a new functionality that I haven't explored when I was writing this code. I should probably look into this as well. But I have all the other operations. You can see you can read item, replace item, upsert item, etc. And here inside this transactional batch, well, I have a new transactional batch that I'm constructing here based on the partition key. And this is where things get a bit weird because like the API doesn't have an internal way to figure out the type of the partition key. So I have to tell it, well, it's a string or it's a bool or it's a number. And that's where this functionality kind of kicked in, this me having to configure this explicitly. But I might figure out a way to not have to do this in the configuration, just determine it automatically. And then, so we have the partition key, and then we set that in the transactional batch. So we create a transactional batch. And then we basically, based on the operation, we put in the bytes of the message. And here there's just some massaging with the generating of the new UID if the message doesn't contain it already, but you can ignore that. And this is basically, hey, create the transactional batch, execute the transactional batch. If it fails, well, reject the whole batch. And it gets a bit weird because I've seen that the API can return a failure in multiple ways. First, you have this error here, which I guess is client-side validation. And then this is probably the server-side validation, where you get no error here, but you get a response with not success status. So you have the success set to false, and then you get a bunch of operation results for each transactional in the transactional batch. And you have to look at the status code, but the status code is not super descriptive. Like, for example, if I put in a message without an ID, well, things are pretty cryptic and you don't really know why. You can also print the number of RUs and the activity ID here for troubleshooting. So I'm logging that information as well. The consumed RUs are basically how much used, request charged. Okay, and then what else? Well, we can also, as a quick example, I think I had the deletion. So here what I'm doing is I'm selecting all the IDs from that container, and I'm running the delete operation. So let's look at that as well. So you see, just deleted these messages, and if we go here, emulator should see a very empty container, hopefully. Yeah, it's empty. So yeah, this kind of concludes the demos I wanted to show you. Not sure if you have any other things you'd like me to cover, but that's all I
No,
have.
that looks really good. I mean, it was awesome to see the live demo using the code. There are a couple of questions on the chat. The first one is, can this be used for data migration from other systems to Cosmos DB?
That's exactly one of the use cases I had, like going from a legacy Oracle database and trying to put that data into Cosmos DB. Like I showed you, if you go again to the Benthos documentation, I should have left my screen share, I think. But if you go to the, let me just share again. If you go here to the Benthos documentation, you'll see, for example, that you have as an input the SQL row or SQL select. And here you can see the drivers that are supported. So you can do a SQL select, for example, from Oracle or from Snowflake, and then take that data and then push it with my output to Cosmos DB.
Got it. Okay. And there is another question. How is it different from tools like ADF or bulk executor for Azure Cosmos DB?
Right. So I'm not super familiar with Azure Data Factory, but I guess, like at the minimal, you can run this wherever you want. Like, let's say you can only push to Cosmos DB for whatever reason, like your on-prem data source just sits somewhere, it's pretty locked down, and you can run this Benthos thing on-prem next to your data source and push data to Cosmos DB.
Yeah, that's all we had on the question side. I know that we are on time as well, but this was awesome.
You're welcome, Sanjay.
I mean, with the demo, love to have you in another session talking about the implementation further once you have that PR merged. But thanks for your time, and thanks for sharing these insights. Thanks, audience, for all the questions as well. We'll wrap up this session. Thanks, Mihai, for joining.
Thank you, John. Yeah.
Happy holidays and happy Christmas. Bye.